Hi, in this video we are going to talk about partition function of quicksort. We'll first talk about partition function. We will understand it well so that we can quickly understand quicksort. So we are given an array, an unsorted array obviously, and we are given index of an element inside this array. So I'm given this index P as 5, which is index of the last element 7. So the requirement of the partition function is it should partition the array around 7. All the elements before 7 should come before it. All the elements greater than 7 should come after 7. If there are elements which are equal to 7, they should also come before 7. That's the requirement. There can be multiple possible outputs of the partition function. You can have 3, 6, 7, 8, 12, 10. Here all the elements here are smaller than 7. All the elements are greater than 7. But there can be multiple permutations of these elements and these elements. For example, this is a permutation. This is another permutation. So you can have multiple possible outputs and any of those outputs is valid. So your partition algorithm can either change this array to this or any other array where 7 is at its correct place and all the elements before 7 are smaller and all the elements after it are greater than 7. Please pause this video and try to think of a solution that partitions the array around a given element. You may think of different solutions. We'll talk about 3 solutions of this problem. One is naive solution, then there is an algorithm called Lomuto partition, then there is another algorithm called Hoover's partition. We'll talk about these 3 algorithms one by one. Let us now talk about naive solution to partition the array around a given pivot. Let's take a look at this example. We are given this array where low points to this element, low is 0 and high points to the last element. And we are also given the partition point as last element. So indexes are from 0 to 6, 0, 1, 2, 3, 4, 5, 6. So P and H both are 6, both are last elements. So L and H represent the whole array and this element represents the element around which you want to partition. So what do you want as an output? You want to put all the elements which are smaller than or equal to 8 on the left side and all the greater elements on the right side. So your output should be 5, 6, 8. And then 9, 12, 11 and 13. These elements can come in any order. These elements can come in any order, but they should come before 8 and they should go after 8. Let's see how does this work. How does this partition function, naive function work that we have written here. So what does this function do? It creates an array of size temp which can hold all the input elements. How many input elements are there? L is 0, H is 6. So you will have 6 minus 0 plus 1, 7 elements. So you create an array of size 7. First, you copy all the smaller or equal to elements into this temp array. So after this step, what will happen? Your temp array will contain 5, 6 and 8. We traverse through the input array. For every element, we compare it with the pivot element or the element around which we want to partition. If it is smaller or equal to, we put it in the temporary array and we increment the index, right? So we have 5, 6, 8 after this step. Now in this step, we put all the greater elements. So we have 13, 9, 12, 11, 9, 12, 11. And you can see that our temporary array has the partitioned array. It has all the elements which are smaller than or equal to 8 on the left, all the greater elements on the right. So what all we need to do now is copy this temporary array back to our original array. So we copy these elements back to our original array and our original array becomes a copy of temp, which is 5, 6, 8, 13, 9, 12, 11. So this is a naive way of partitioning. It requires 3 traversals and also requires big O of n extra space. So auxiliary space requirement by this is big O of n, and time is big O of n. But it is like doing 3 traversals of our input array. So can you solve this problem with big O of one extra space? We'll talk about that solution, Lamouito partition solution, in the next video.